Before trees or dinosaurs, Earth was a hot, stormy world of dark oceans and boiling rock. No oxygen, no blue sky, only lightning, volcanoes, and mineral-rich water. Somewhere small, maybe a tide pool or a deep-sea vent, simple molecules got a spark and started to team up. One day, a tiny bubble of chemistry learned to copy itself, and everything changed. How did lifeless stuff take that first step into life? We do not know the exact day life began on Earth, but we know it was long ago, more than 3.5 billion years in the past, when our world was hot, noisy, and raw. The sky had no safe blue shield because there was no ozone yet, and hard rays from the sun came down like bright spears. The air was thick with steam, carbon dioxide, and nitrogen, with sharp sulfur from many volcanoes, and almost no oxygen at all. The ground shook often as black lava spread and cooled and cracked, while dark ash drifted down like snow and made the light look dim. Out past the beach, the sea looked green and sometimes rusty from iron in the water. And slow swells moved under a pale sun and a fat moon. Warm rain fell, stopped, and fell again, so puddles formed, dried, and formed again, a steady beat that never tired. The moon pulled hard on the water, so tides ran far and mixed everything again and again. On that unknown day, nothing walked on land. No trees, no grass, no birds, no bugs, not even moss. There were only rocks, sand, clay, and pools that steamed, hissed, and bubbled. Yet the place did not feel empty. Heat pushed up from inside the planet, and cold pressed in from the deep sea. And where the two met, energy flowed and did quiet work. Down on the seafloor, long cracks let hot water shoot out of vents. Around those vents, chimneys of minerals grew as hot water met cold water and dropped solids that stacked into walls. Up near the shore, clay formed in thin sheets with tiny spaces between the sheets. Those spaces had soft pulls that could catch passing molecules and hold them close while the tide rose and fell. Each tide laid down a fresh mud. Each dry spell pulled water away and pressed the caught bits together. Then the next wave spread them out and brought new bits to try. You would smell sulfur and warm whetstone, hear hissing, and see steam lift from black flows that cooled to dark glass. Nothing in sight had a face, yet it felt like a held breath. The parts for something new were all around, waiting for a spark, a tilt, a lucky step. Water was the great mixer, and there was plenty of water. Carbon and nitrogen were in the air and the sea. Minerals were fresh, with many places to grab and guide. Light came each morning and night came each evening. And that switch from warm to cool and wet to dry turned the planet into a slow, patient lab. Even without a mind, the world was running tests. Little bits drifted together on a rock face, then broke apart and tried again in the next pool. Some stuck longer when the water was warm. Some stuck when it cooled. We cannot point to one rock and say, "Here on this hour," but we can see how the stage was set. Earth had cooled enough to keep oceans. Big impacts had slowed, so pools could last more than a few hours or days. Volcanoes fed the air and water with gases, heat, iron, and sulfur. Storms charged the sky and drove lightning into puddles and thin films. The moon, closer then than now, tugged on the world and made strong tides, and the tides brought mixing and fresh starts. In the deep, vents gave steady energy without sunlight. Both places were harsh, yet both were rich in what tiny systems need to try again. In very old rocks, we now find signs that match this picture. We find chemical hints that say, something here took in one kind of carbon more than another, the way life does. These hints show up by 3.5 billion years ago and maybe earlier, which means the first steps had started even before that time. So the first act of the story is not a hero with a name, but a world of heat and water and rock and light that sets rules and says, try this, try that, repeat. This is where contrast lived. Hot next to cold, acid next to mild, salt next to fresh, dark next to bright. And at each border, small items had a chance to line up, to copy a little, to hold a little, to last a little longer than chance. On that day, the planet tapped its notes with tides, storms, lava, rain, and time. Each tap made tiny changes. Each change stayed if it helped a small pattern hold together. Most trials failed, but a few held for a breath, then a minute, then an hour. In a warm pool, a film might have spread, thin as a soapskin, then popped, then formed again when wind calmed. In a vent wall, a chain of atoms might have formed, and then copied part of itself, not well at first, but a little better the next time. A clay edge might have lined up simple pieces in a neat row so they could snap together faster than chance. From far above, the planet turned, wrapped in cloud and steam, the sun lighting one half, the moon tugging the seas. This is the feeling of the unknown day, not a flash, but a slow, steady press of natural steps. Later, tiny cells would breathe and eat and change the air, but not yet. For now, the promise was enough. The world had the right parts, the right pushes, and the right pauses. It had time, and time is the biggest tool of all. And so the day life began might have looked like any other day to a stone or a wave. But inside one small place, the pattern that would lead to us took a first tiny hold, and the quiet planet, still hot and wild, moved one small step closer to being alive. The air on that day felt thick and strange, like warm breath held inside a giant room with no windows. There was almost no oxygen to help anything breathe, less than 1 part in 1,000, so no one could take a clean, deep breath the way we do today. Most of the air was nitrogen, quiet and dull, and a lot of it was carbon dioxide, the gas that traps heat. Steam rose from ponds and seas and vents, making white veils that curled and faded, then formed again. Tiny bits of sulfur from volcanoes gave a sharp, burnt smell that stung the nose, and ash grains drifted down and coated wet stones. Without oxygen in the sky, there was no ozone to make a shield, so hard rays from the sun rained down and stung skin and eyes. The light was bright, but it was also harsh, and it broke weak bonds as fast as they formed near the open ground. The sun itself was dimmer than the sun we know, about 1/4 less bright, but the thick air helped hold heat near the ground. That is why the ocean stayed liquid and did not turn to ice even with a weaker sun. The air worked like a thin blanket that covered the world, trapping warmth from sea and rock. When wind pushed that blanket, it made long bands of cloud that wrapped the planet like belts. Rain fell hard, in fat drops that hit dust and made tiny craters in mud, then steamed as warm ground met cool water. Between storms, the air felt heavy and still, and heat rose in waves that blurred the view. Lightning was common, bright lines that snapped from cloud to cloud or from cloud to ground with a crack and a long roll that shook the chest. In the count of 1 minute, a storm could flash many times, and the smell after the flash was sharp and clean like stone washed by a wave. The bright spark of a bolt split molecules and made new ones. The air was a busy workshop where light, heat, and water took simple gases and turned them into new parts. Near the ground, those parts mixed with spray from waves and with dust from lava and clay. Some parts fell back to pools and stuck to rocks, where they had a chance to last a little longer. Because there was no ozone layer, the strongest parts of sunlight. The short waves we call UV reached the ground and the sea surface. Those rays could break apart fragile chains that had just formed, and that was the danger. But the same rays also gave energy that could help new bonds snap into place. So the air gave and the air took away, again and again. Under a thin film of water or under a grain of clay, the harsh light grew softer, and fragile chains had time to hold. Wind mattered too. It came in long sighs over the sea and in short, wild gusts near hot land. It moved heat from place to place and mixed the air so fresh gases reached pools that needed them. Dust rode the wind like tiny boats. Iron dust turned water a faint green, and ash darkened puddles until the next wave washed them clean. When the wind dropped, the world grew still, and in the stillness thin skins could form at the edge of a pool or across a tiny bubble. When wind rose again, many skins would tear, and a few would hold. The ones that held might trap new parts inside, and those parts could work together a little longer. The pressure of the air may have been close to what we know today, or a bit higher in some places, but no one can say for sure. The important thing is that there was enough air to move clouds, carry storms, and feed waves. This moving, living sky pressed against every pool and every rock, and every press helped small pieces meet. When a cool night came, steam turned back to droplets and dripped from rock faces into bowls and cracks. When the sun rose again, heat turned those drops back into vapor and pulled them into the sky. The air breathed in its own slow way, day after day, breath after breath. On some days it looked pale and washed, like a sheet left in the rain. At sunrise and sunset the colors deepened, and the whole dome glowed red and orange, because the light had to pass through so much air. If you climbed to a vent field on a young volcano, you would see steam roar and small jets spit from cracks. The air near those vents felt hot and metal-tanged. If you walked to the beach, the air felt heavy and wet, and salty spray coated your lips. All of this air was a stage and a tool at once. It spread gases around the world. It brought water where it was needed and took it away when the heat rose. It carried heat and smell and ash and tiny seeds of future change. There was a promise tucked into the air that day, a promise that later would be kept by tiny builders. Long after this time, small cells would learn to use sunlight to split water and make oxygen. That new gas would rise and change everything. It would make an ozone layer high above, a thin blue shield that blocks hard light. It would let breathers thrive and build big bodies and bright colors. But on this early day, before any of that, the air was still the old mix, simple and harsh. It was the right kind of harsh, the kind that makes many tries and keeps only what can last. The air hummed with quiet work. You could not see it unless you looked very close, but you could feel its force in your skin, your eyes, and your chest. It made storms that rolled over the sea and broke on black rocks. It stacked clouds into towers and tore them down. It fed the heat engines below and carried new smells from far away. It was not kind, but it was not cruel. It was busy, and in that long, busy day, it set the terms for what came next. Later, when the first tiny cells left clear marks in stone, they would do so under a different sky, one they had helped build. But the start of that change lived here, in this thick, hot breath of a world where every gust and drop and spark wrote the rules in the air, always. The sea on that day reached almost everywhere you looked, a wide skin of water wrapped around the world and shining like dull metal under a pale sun. It was not the calm blue of postcards. It was darker, green in many places, and the color of tea in others because it carried minerals and tiny bits of rock in every slow wave. The water felt warm in the shallows like a bath near lava and steamy cracks, and cooler far from land where the depth ran down. Spray stung your lips, and the air tasted of salt. Islands were small and new. They rose like dark backs of sleeping whales, bare and wet, with thin white edges where waves polished rock. At their feet, the sea chewed every crack, filled them with water, pulled away, and pushed back again. Each rush took a little dust and left a little sand. Lava that touched the surf cooled so fast it made smooth glass pillows that stacked and broke. Between the stacks, small pools warmed in sunlight and then dumped back into the surf when a big wave came. If you climbed a ridge and looked out, you could see long bands of color on the water, like paint brushed in stripes. Some bands were darker because iron had dissolved there and gave a rusty green glow. Some bands were lighter because fresh rain spread a thin blanket of soft water on top of heavier salt water. Where the bands met, swirls spun coins of foam that danced and slid away. The smell shifted with the wind. Salt and wet stone, and a hint of sulfur from far vents. Your tongue could taste a faint metal tang if you stood near new rock. Below the top skin, the sea held layers. Warm water floated above cooler water, and the border moved with storms and with night and day. At noon, the top hand's breadth warmed first and sped up. At dusk, that skin cooled and sank and mixed with what lay below. Deeper still, the world grew quiet and dark. The water touched the young crust, picked up heat from inside the planet, and gathered minerals from tiny cracks. Long ridges crossed the seafloor like seams, where new rock pushed up and hot water seeped from small vents. The sea was a giant mixer, with tides that were a slow, strong stir. Rivers of rainwater ran down new slopes and brought bits of ground into the surf. Dust blew in from dry places and laid a thin skin on the water that the next breeze tore. In quiet hours, things that had been shaken apart met again by chance on a grain of sand or a slice of clay. Some stuck for a breath and washed away. Some held for a minute and then let go. The tide kept time for all. Not all places were kind. The open surface under hard sun broke weak bonds as fast as they formed. But take one finger's length of depth and the light softened. Take a hand's length and it softened more. Tuck in behind a stone, and a small shadow gave fragile things a little time. In the foamy edges, thin skins formed around tiny bubbles, burst, and formed again. In wide, shallow flats, water spread thin over mud, warmed fast at noon, then drew back when wind changed, leaving damp films that dried and cracked. Out beyond the islands, long swells from far storms rolled for many miles without breaking. Near a headland they lifted into pale green walls and folded into white. In the open, dust and tiny grains sank like slow snow and made soft blankets on the bottom. Bits of glass from old lava, metal-rich ash, and tiny crystals from deep places all found spots in those layers. When a new flow buried them, it pressed them into stone pages for another age to read. If you dipped a cup of water near a fresh shore and let it rest, faint specks would settle out. Some were red-brown, some gray or black. A thin skin might form on top, a fragile film that winked before it tore. If you swirled the cup, the film would fold and make little pockets, then smooth out again. The simple play set a pattern. The sea made many small rooms, closed and open, again and again, each one holding a brief chance for new steps to try. The weight of the water pressed on everything and made rules. It slowed wild jumps and cooled hot rock. It tucked gas from the air into the top layer, then gave some back when waves burst into spray. It hid light so quickly that a hand held out at a short depth looked like a dark leaf. The sea was both shield and hammer. It saved fragile work from harsh rays, and it smashed flimsy work that could not stand a push. There was danger in the sea, but there was also promise. Warmth without fire, motion without breakage, shelter without walls. The contrast was the key. Hot next to cool, salty next to fresh, still next to stirred, shallow next to deep. Along every border between those states chances bloomed. What could not last in glare might last in shade. What could not form in cold might form when a thin film warmed at noon. What fell apart in fierce surf might hold in quiet water tucked behind a stone. This restless edgework trained the world to try again. Later, when the first small cells began to live and leave signs in stone, much of their early work would still take place in water. It would happen on wet grains, in films, in cracks, and in the slow drifting dark. But on this day, before any cell had a name, the sea was only setting the table. It laid out salts, metals, gases, and heat in many small patterns, and kept the pieces moving so they could meet again. It was patient, it was tireless, and it covered almost all you could see. The ground shook with a slow, deep rumble, like a drum rolling under your feet, and the world of rock woke up. Volcanoes rose as black cones along young coasts, and long ridges hid under the sea like sleeping spines. When a vent opened, it breathed out steam, carbon dioxide, and sharp sulfur, and the air tasted like a blown-out match. White banners of vapor curled upward and spread, and a gray snow of ash drifted down and coated warm stone. The cone coughed again, and the day of fire and rock truly began. Lava poured from cracks and ran like bright rivers down new slopes toward the water. It came out orange and fierce, about 1100 to 1200 degrees, hot enough to light the bellies of clouds at noon. On gentle ground it slid like thick rope and folded into shiny, wrinkled skins you could press with a stick before they cooled. On steeper ground it broke into clinking blocks that scraped and tumbled, a field of knives that could slice a bare foot. Where the flow met the sea, it snapped and popped, threw glassy crumbs into the surf, and puffed into round pillows that stacked like loaves. Steam roared, salt hissed, new rock tumbled forward, slow but sure. Not all fire rose from neat cones. Long cracks opened without warning and poured broad sheets across flat land, their edges creeping a few meters each minute until the ground tipped and the sheet leaped faster. One run could travel for many miles and turn a low basin into a red lake that glowed after sunset like a river of stars. Heat from inside the planet was stronger than it is today, maybe 2 or 3 times as high, and that extra warmth kept the crust thin and easy to split. Far under the ocean, fresh sea floor rose along a ridge that circled the world for thousands of kilometers. There, hot water burst from chimneys tall as houses, more than 300 degrees without boiling, black with tiny bits of metal and sulfur. Those bits fell like snow and built the walls ring by ring. Step too close and the scald would kill you. Step back 2 steps and it felt warm. Step back 2 more and it cooled, and in that narrow edge small chances gathered. The sound of this day never stopped. Deep booms rolled through the ground like slow thunder. Small quakes ticked and talked, some so soft they felt like a held breath, others sharp enough to send pebbles chattering down a slope. Now and then the side of a cone gave way, and a hot cloud of ash and gas rushed downhill faster than any animal could run, hugging the ground and drawing long scars across fresh black rock. On the shoreline, new points built by last week's flows stuck into the surf and then were cut back by the next storm. Steam vents breathed steady, and white crystals grew where sprays cooled on dark stone. The air smelled like sulfur and wet glass. If you stood still, the ground hummed inside your feet. Rocks kept the story in their tiny parts. Bright yellow crusts formed where sulfur met wet stone and cooled. Heavy, brassy cubes of iron and sulfur gleamed in cracks until rain turned them dull. Green minerals grew where hot water soaked cold rock and changed it from the inside, making soft beds here, hard ribs there. Thin seams filled with quartz clear as ice, and those veins acted like pipes that moved warm water up and cool water down in a slow loop. In small pockets, heat drove simple gases to meet and link into new pieces. Some broke at once. Some held for a breath. A few lasted longer under a thin skin of water or a smear of clay. Above the vents and flows, the crust sorted itself by weight. Dark, heavy rocks made most of the ocean floor. Lighter, fatter melts rose in wet places and cooled into pale rafts that tried to float. These rafts were small at first, maybe no bigger than a modern state, and they drifted on the warm, weak shell. When they bumped, they welded at the edges and lifted ridges a kilometer high. When they pulled apart, the sea poured in and the ridge slumped. No map from today fits that time, but you can picture little lands drifting, bumping, joining, and breaking again, while the sea lapped at every side. Fire and water worked as partners and rivals at once. Where lava spread, it brought brand new glassy faces with tiny electric tugs that helped small molecules stick and line up. Rain on fresh ash made gray milk that ran into pools and left mud rich in iron that turned red in some spots and black in others, painting the ground with bands that marked wet, dry, and in between. Waves ground new points into sand, and the sand held tiny magnets, iron grains that clicked against stone when the surf pulled back. At night the warm flows glowed like coals under a thin veil of mist. By morning, calm puddles grew shiny crusts and then cracked into plates when the wind rose. Danger and help stood shoulder to shoulder. A thick fall of ash could smother a quiet pool that had grown sweet with parts, but it could also seal that pool with a lid and keep its mix safe from harsh noon light. A hot surge could boil a beach flat, but it could also leave a warm, wet plain pocked with shallow ponds in each hollow where stones had bounced. A tongue of lava could cut off a stream and force it into a wide, thin fan where films formed on clay and tried new shapes while midday heat pressed like a steady hand. The world did not plan, but it made room for many tries. Even the sky helped the work. Tall columns of hot air pulled winds from every side, and those winds carried ash far out to sea, where it fell like gray snow on the skin of the water. Each flake brought metals the surface could taste, and that taste sank with popping bubbles and rolling foam. Storm clouds built over warm flows and dropped rain with a hiss. Lightning stitched cloud to ground again and again, each flash splitting gases into pieces that could join in new ways when they cooled. As hours passed, some flows formed tunnels that carried their hot hearts forward, hiding the glow and keeping the melt alive for many more meters. At the lip, a tunnel broke and poured a fresh sheet into the waves, and new pillows tumbled over old ones like a slow waterfall of stone. Behind the front, roofs sagged and fell and left skylights where steam blossomed with a roar. In those pits, rain later gathered and made warm ponds that steamed at sunrise, went still by noon, and shrank to rims of salt by dusk. Far away, Big space rocks struck less often than before, but now and then a bright stone crossed the morning sky and ended in a white flash and a deep boom that pushed a wall of air across the water. Small pieces came much more often, a dusting of nickel and iron beads that hissed when they hit and made tiny pits in warm mud. Each strike churned ground, baked clay, and made fresh glass. Each strike also reset the stage, sweeping clean and seeding new surfaces for the next round of tries. Night did not bring silence. Vents kept breathing above 300 degrees, and their chimneys kept growing, ring by ring, like trees of the dark. The ground still ticked with little quakes, and the warm match smell drifted low through the hollows. If you knelt by a cooling flow, you could feel heat on your cheeks and chill on your back, a clean split that taught the same lesson again and again. Contrast makes chances. This was the work of fire and rock. It broke and built, heated and cooled, covered and uncovered, and wrote lines the sea and sky could read. Later, tiny cells would stack soft stone towers and leave layered mounds as proof of their patient lives. Later still, breathers would fill the air with oxygen and raise a blue shield against harsh light. But on this day, the planet's heart did the lifting. It set the table with warm pools, iron-rich mud, fresh glass, steady vents, and ground that shook just enough to keep the parts moving, while the gentlest work began to stir within the heat and stone. Shallow places kept secrets on that day, small corners where the harsh world grew softer and let fragile things try to live. Along the young coasts, tide pools dotted dark rock like mirrors. Some were the size of a hand, some as wide as a room, none very deep. Twice each day the sea rushed in and filled them, and twice each day it slid back and left them to sun and wind. When water stood high, the pools felt safe and cool, a few finger widths deep, the light gentle and green. When water dropped, the pools turned into thin films and damp mud, warm to the touch and full of tiny hiding spots. Salt drew white rings as it dried, hour by hour, like a clock. Grains of clay made soft beds. Sand made rough floors. Ash made gray milk that settled into smooth sheets. In that up-and-down rhythm, the pools gave both shelter and push, a steady beat telling simple pieces when to meet and when to rest. One pool sat in a bowl of black glass, where lava met sea. Its rim was rough with pits and sharp edges. The floor held soft gray mud rich with ash ground fine by waves. Each high tide spread a fresh dusting of iron and clay. Each low tide left a thin film over the grains. The film was a fingernail, thick at most near the edge, thicker in the middle where water lingered. Under this soft cover, harsh light faded, and heat rose just enough to help new bonds snap into place. By sunset, the pool became a patchwork of shiny skins and cracking plates curling like dry leaves. A second safe place lay under a flat rock, a slab no bigger than a door resting on 3 small feet of stone. A thin stream ran under the slab when waves climbed the shore. When water fell, the stream slowed to a line of wetness, then to beads that clung like stars. The shade made a cool cave as long as a person is tall, barely the height of a hand. The air moved but gently and the light was dim. Harsh rays could not reach there, yet dust and spray still could. Bits of salt lined the roof like frost. A skin grew over little puddles and trembled when distant waves thudded through the rock, then smoothed again. Farther out, a raft of pumice drifted in a sheltered bay, slabs of pale stone full of holes. Their holes were tiny rooms, many no wider than a grain of rice, some the size of a pea. When rain fell or spray flew, each little room filled and then slowly leaked. Wind and waves rubbed the pumice against glassy rock and broke off crumbs. Down the beach, foam piled in thick white banks along a line of black sand. Bubbles wore thin coats that shone with oil colors for a breath before they popped. Some coats folded into doubles and triples, tiny sacks that rolled into cracks and lasted for a few more heartbeats. Salt made the water heavier there, and wind pushed it into corners so films could last longer than in open surf. Even on cool nights, dew beaded on stone and ran in lines that filled small dents. By dawn, those dents were round pools the size of coins, their rims white with salt. When sun warmed them, they shrank into rings and then into dark dots. But their short lives were long enough for work that could not stand open day. Safe places did not only hide from danger. They used danger in small doses. A flash of lightning split gases above a pool and made fresh parts that sank with the rain. In the next hour, the sun's hard rays hit, but only the top skin felt the bite. The skin broke and took the harm so the layer below could try again. On a shaded beach, wind drove spray through wet sand and left a thin, salty crust that trapped small pieces under it like a lid. Threads of water ran through cracks inside new basalt, barely a hair wide, but long, winding paths. In those hair-thin rivers, flow was slow and smooth. The walls held places for tiny parts to rest and line up. At the mouth of each crack, surf frothed into foam. Bubbles rose with thin coats, soft circles of shine. Many burst at once with a hiss. Some slid into corners where the film could thicken and fold. The safest places had just the right size. Too big, and good parts washed away. Too small, and nothing could move. A hole the size of a bean, a film as thick as a leaf, a crack as wide as a hair. These were sweet spots. A pool that filled and drained in a handful of hours made a good rhythm. A wall that felt warm but did not scald gave a good speed. A shadow that cut light by half took away the worst harm but left enough glow to help. The world did not aim for these numbers, but rock, water, and light kept landing there. Far below, along a ridge on the seafloor, other safe places were warm, not boiling. Towers rose from mineral snow, pierced by little passages like a honeycomb. Near the mouths, water rushed out scalding hot, black with tiny grains that winked as they turned. A few steps to the side, water cooled to the warmth of a bath. 2 more steps made it like a stream. At those edges, heat and cool met in a narrow band, and that band was kind. Warmth gave speed to slow steps. Cool held new shapes together. Iron and sulfur in the walls pulled simple bits close and held them long enough to meet. The sea kept fresh food coming and carried waste away. The place was not quiet, but it was steady, and steadiness mattered most. You could walk the same shore for a week and see the plan repeat in many shapes. A ring of salt showed how far a pool reached at noon. A rim of red-brown told where iron had kissed air. Short, pale tubes on a black rock marked old chimneys that once breathed warm. In the quiet hours you could notice a smell like matches under one ledge and a sour tang under another. Clay felt slick like soap. Sand rasped like sugar. A film clung to your finger for a second before it gave way. Every sign said the same thing. Here the world is gentle but not too gentle, busy but not too wild. Here a thin skin can form, hold, break, and form again. Here a tiny room can fill, drain, and fill again. Here a weak bond can start, pause, and start again. Later, when small cells at last learned the trick of faithful copying, many would choose these rooms. They would live in warm films, in vent walls, under stones, inside tiny holes. They would feed on gentle flows and steady gifts brought by tide and breeze. But on this day, before any cell had a wall it made for itself, The planet lent out walls and windows. It offered pockets and pores, lids and skins, cool shade and warm touch. It kept watch against harsh light and wild waves by cutting the world into many calm corners. In those corners, slow steps could add up. The big world roared and flashed, but inside the safe places the work that mattered moved forward by inches. Step by step, it prepared a home. The world acted like a careful cook, turning simple stuff into something new. Water was the bowl, heat the flame, rock the spoon. The air brought ingredients, carbon from carbon dioxide, nitrogen from quiet gas, sulfur from vents, and dust of iron and nickel on whetstone. Lightning drew bright lines and gave sharp jolts. Sunlight added a steady push, softer under a skin of water. In this mix, tiny parts began to meet. Most drifted past, but some touched and held for a breath. And that breath was enough for another try. Short chains and small rings formed when sparks hit damp air, when hot rock kissed cool wave, and when steam rose from cracks and cooled in shade. The sea carried them to pools and films. Tides moved in and out and kept them close. A few drops could hold millions of pieces far smaller than dust. Most meetings failed, but the mixing never stopped. When one link held through noon and night, the next morning began with a small head start. And the next link had a better chance. Clay helped the parts meet. Its flat sheets had gentle pulls, the way dry hair lifts a scrap of paper. A speck no bigger than sand could hold hundreds of tiny pieces against its face. Warmth made them wiggle. When water slipped away, pressure pushed them together, and a click could happen. When the tide returned, some clicks let go and some stayed. The ones that stayed took a step toward longer chains, and longer chains could push later steps a little faster than chance alone. The rhythm of the planet mattered. Wet gave freedom. Dry gave pressure. Warm made motion. Cool gave rest. Day and night, tide and calm, storm and clear, worked like hands that knead dough again and again. Each cycle asked, "Will this hold?" Most answers were no, but the maybes added up. On a good edge, a film as thin as a leaf warmed a few degrees at noon and cooled when a cloud slid by, and that tiny swing changed, which links could form and last without breaking. Minerals wrote rules of their own. Iron could give or take tiny charges. Sulfur could link parts into bridges. Nickel and zinc could steady a shape long enough for the next link. Fresh basalt glass had bright spots that pulled certain pieces hard. In the deep, along warm vents, walls of black and cream minerals let water pass through little pipes. On one side, the water held more tiny charges than the other. That gentle difference worked like a battery and drove quiet steps forward all day. Simple chains were not alive. They did not eat or breathe, but some bent into shapes that held other pieces in place. Shapes sped up slow steps, like a smooth slide that lets a heavy block move with a soft push. A bent chain might help two small parts meet just right, then drift off and help two more. The chain did not plan. It fit, and the fit made work faster. Bit by bit, little helpers appeared and stayed longer before breaking in the swing of heat and salt. Other chains held a kind of short code. Picture a row of beads where each color means a tiny choice. If a chain helped add a bead that matched a bead on another chain, a clumsy copy could begin. Warmth shook the copy loose. Cool time let it link again. Mistakes broke many trials. Once in a while, a short stretch matched well enough to grow a little longer, and those inches mattered. Copies were still rough, but now they could last from one tide to the next in lucky rooms. Greasy pieces joined the mix. They had heads that loved water and tails that hated it. When enough gathered, they turned tails inward and heads outward, making a thin skin. On a good day, A skin curled into a tiny bubble and trapped a few chains inside. A breath of salt or a small rise in sourness made the skin tighten. Fresh water made it swell. A skin that held through those swings gave its cargo a private room where slow steps could last longer than in the open pool or surf. Not every place made the same parts, and that difference mattered. Near a cone, sharp sulfur smells marked chains that grabbed metals. Under a cool slab, gentle chains curled into soft loops. In a pool that dried to a thin crust by afternoon, longer chains formed because water squeezed them close. Down along a warm vent, simple rings formed inside mineral pipes, then slipped into the flow to meet other rings. Chance ruled, but numbers helped chance. 1,000 bubbles a second along a shore. A try in every grain of clay on a beach as wide as a town. With big numbers, meetings happened often. Energy came in many flavors. Lightning gave a hard kick. Sunlight gave many soft taps. Heat from rock gave a steady push. Cool night took energy back and let weak shapes fall apart, which also helped by clearing bad paths. The best paths could ride the average day, a swing of 10 or 20 degrees between noon and night, a change in salt as a pool filled and dried, a nudge when fresh rain washed the shore. The world kept what worked and trimmed what could not handle the daily swings. By last light, pools and films and vents had done more than make parts. They had begun simple talk between parts. Helpers made other helpers. Rooms made better rooms. Copies, though clumsy, learned to hold a bit longer. Nothing walked. Nothing thought. But the work now had a direction, not from a plan, but from a fit between the world and its pieces. In the morning the work would start again, stronger by a hair, ready for a spark that one day would be called life. On this day the line between almost life and life grew thin, then thinner, and at last something crossed it. In a warm, quiet corner under a rock by the sea, a tiny bubble made a soft shell around a small mix of chains and rings. It was smaller than a grain of dust, only a few micrometers across, so small you could fit 100 side by side on the head of a pin. Inside the shell, a short code chain found the pieces it needed and began to copy itself. It did not copy well, but it copied enough, and now the next step could try. Nothing about this spot looked special to the beach, the wind, or the waves. Lightning flashed far out to sea, and a low growl rolled in. But inside this one small room, slow steps kept going in a steady loop. Food in that time did not mean plants or meat. The short code chain found a helper shape that held 2 parts next to each other, and they clicked. That helper drifted away and helped 2 more. The cell to be was not a mind, yet it behaved like something that wanted to go on. The shell helped in more than one way. It kept good parts near and let waste drift out through thin spots. When the pool warmed by 10 degrees at noon, the shell flexed and let new pieces in. At night the bubble bumped other bubbles and sometimes traded bits when their skins touched. By dawn the bubble held more code chains than before. A few had shapes that could help other chains grow. That meant the work inside could run faster than the work outside, and speed mattered. Down on a vent wall far below, a different bubble found a chance. On one side of a thin mineral skin, the flow was hot and full of charged bits. On the other side, it was cooler and mild. The bubble clung to a rough grain where the push from one side to the other never stopped. It was like a very small battery, only a hair from one pole to the other. Each second the bubble used that push to add a bead to one of its chains. The chain curled and helped make a match. Not every copy was a win. Some chains grabbed the wrong thing and jammed the works. Some shells let in too much salt and fell in on themselves like popped soap. A warm gust sent sand over the pool and tore many films. Loss was part of the day. But the numbers were on the side of life. In 1 square meter of wet clay there could be more tiny rooms than stars you see on a clear night. In each room the same patient tries went on. A moment came when one bubble's set of tricks fit together so well that it began to outgrow its neighbors. It could mend its shell from pieces it made itself. It had a pore that opened wide when the salt outside dropped, and closed when salt rose, so it could drink fresh water and spit out brine. It had a short chain that clung to iron and passed a charge down a line, and that line drove the next linking step. None of this was planned. It was fit upon fit, kept because it worked long enough to make more. If you could watch with eyes that see the very small, you would see this speck hunt in its slow way. It moved by drift when waves shoved it, but inside it ran on rules. When the water around it held more of the parts it liked, the shell let in more of them. When the water ran short, it slowed and waited near a grain that leaked a little of what it needed. In the vent field, cousins did the same with heat and flow, hugging the band where hot met cool. They lived on chemistry alone. Size stayed small. Most of the first true cells were only a few micrometers across, 10 times smaller than the width of a hair. They divided in minutes or hours when warm, in days when cool, and in longer spans when food was thin. Each split made 2 specks that were almost the same, but not quite. In those tiny differences lived the next steps. A chain that folded a little tighter might stand up to heat better. A pore that opened a touch faster might drink sooner when rain freshened a pool. A shell that stuck to clay with just the right pull might ride out a tide. The world outside did not notice, but the balance began to tip. Where there had been only chemistry pushed by chance, now there were cycles that kept their own time. A cell that split and left 2 behind doubled the chance that one would be in the right place at the right hour when the next tide rose. Little wins like these made new ground for the next round. No one wrote the rules, but rules took shape. Use what is near. Shield what is weak. Trade what you can. Keep what keeps you. When heat is high, hold fast. When cool returns, repair. Each rule was born from the push and pull of the place, and each rule fit the parts that survived. Slowly the set of rules turned into a way to live. Life did not shout. It whispered and persisted. It leaned into chance, and turned chance into habit. As the sun dropped, the beach looked the same as it had that morning. Wet rock, thin pools, soft wind. But much had changed in places no eye could see. Some shells learned to rebuild after a pop. Some chains learned to help other chains join. Some rooms learned to catch a stray code bead and read it. The best sets of tricks spread not by mind, not by plan, but by one plain test. They made more of themselves before they broke. In the days ahead, new light tricks would appear, and one day the sky would start to change. For now the first living things stayed small and quiet, tucked in safe places, working by feel, and turning a wild world into a home one tiny step at a time. And with every tide and spark, more makers joined the work, turning luck into pattern and pattern into purpose. The clues were quiet, but they waited for anyone who learned how to look. A cliff of old rock stood like a book, each thin layer a line of Earth's story written before any tree or fish. Sunlight showed stripes of black, red, and gray. A hammer tap split a thin plate that smelled of wet stone and iron, and lines ran across it like ripples frozen in time. Long ago, tiny mats of microbes trapped grains of sand and glued them with sticky stuff they made. When waves rolled over, more sand stuck, and the mat grew a little hill. When the tide fell, it dried and stiffened, and a new mat grew on top. Layer on layer, those skins built stony mounds called stromatolites, some a few centimeters tall, others a child's hand, high with round tops and narrow bases that show where water once flowed. You can still visit such rocks today in warm, shallow bays, but the oldest signs sit far back in time in Australia, South Africa, and Greenland. There the stones are hard and dark, with patterns that look like tiny towers, cones, and ripples, and under a lens each shows layers as thin as a grain of salt. No animal or plant made them. They are the slow handwriting of mats. Not all clues are shapes. Some are weights hidden inside atoms. Carbon can be a little heavy or a little light, and living things prefer the light kind when they build their bodies. In ancient black rocks, the carbon is lighter than in plain stone, by a few parts in 100, steady and clear, whispering that life was working back then, even though no shell or bone remains. Iron tells stories, too. Bands of iron-rich stone lie across old lands like ribbons, sometimes as thick as houses and as long as valleys. Long ago, iron in the sea met oxygen and fell like rusty snow to the bottom. Where did the oxygen come from in a world with almost none in the air? Drop by drop it came from microbes that used sunlight to split water and let out oxygen as waste. The sea took that breath and fed it to iron, and layer by layer a band grew. Some stones keep the touch of soft bodies. In shallow flats, mats made a thin, sticky skin over wet sand. Wind drew lines. Raindrops pocked the film, and the next tide laid mud across it while the skin kept its shape. These mat marks show how a living skin held sand, so ripples froze when they would have slid, and curls stood when they would have fallen. There are clues older still but softer. Tiny crystals of a hard mineral called zircon formed when the world was young. Some hold a whisper of old water in the way their oxygen sits, saying that by over 4 billion years ago the surface was cool enough for liquid water to pool. That does not prove life, but it shows the stage was ready. Old rocks hold sulfur clues, too. In ancient layers, sulfur atoms carry odd patterns that form when the air has no shielding ozone and almost no oxygen. Later layers lose that pattern, marking the slow rise of oxygen made by tiny life in the sea. It sets a timeline, first chemistry under hard light, then hints of breath, then a sky that begins to change. Not every mark is trusted at once. One famous set of tiny shapes in a black stone looked like cells under a microscope, but later teams showed heat and pressure could make the same lines without life, so the claim was set aside. This careful work keeps the story honest. When many clues agree, shapes in stone, light carbon in powders, iron bands in cliffs, ripples held by mats, the case grows strong, and we can point and say with care, life was here. Fieldwork ends in labs where trays hold numbered bags of chips and powders, and labels read like a code: site, bed, height, thickness. In quiet rooms, lasers tap crystals, and mass spectrometers hum while graph lines creep across screens. A small change in a ratio brings a cheer and means one more brick in a careful wall. Other labs repeat the work. The numbers match within a hair. Trust grows. Imagine the day those first mats caught enough light to grow faster than they were erased by chance. They built layer on layer until they touched air at low tide and felt the sun as heat and glare, for no ozone yet softened the light. Yet they held on. Tides brushed them twice each day. Storms tore pieces free, and new mats grew over the scars. A mound became a hill, and a hill a reef for that age, hard as stone because it was stone. and a hand on that fossil hill can feel bumps and ridges made by tiny lives. Walk along a road cut, and you may pass deep time without knowing. A thin black bed, a finger thick, may hold light carbon that marks life at work. A red and gray cliff may be an iron band that remembers breaths from tiny builders. A gray sheet with small domes may be a stromatolite sliced flat by the blade that cut the road. The world keeps its records in places so plain that most drivers never see them. These are the proofs that life began long ago, not in a single flash, but in long, patient work written into rock. They stand in deserts, at road cuts, and on lonely coasts, and they tell us that tiny makers changed oceans and then the sky. Soon those changes would spread, and the air itself would shift. On some far morning, a deep breath would be possible. For now the stones keep a whisper. We were here, we built, we endured, and our marks still shine when sun strikes the cliff face. Begins smaller than dust. A thin film of warm water coats a black rock by the sea, only a few hairs thick. Sunlight reaches it, but clay turns the light soft and green. Heat from the rock adds a few degrees and lifts a faint, salty mist. Inside this tiny world floats a bubble a few micrometers wide. Its skin has greasy tails facing in and heads out. The bubble holds salty water, a dust of iron, and short chains of code. It bumps a flat grain of clay. The clay face tugs at the chains, so they line up. Warmth makes them wiggle. Two beads meet and click. Lightning scribbles across a dark cloud. Rain begins with hot drops, then cooler ones that carry new bits. Tiny rings, simple acids, a breath of sour gas. The film drinks them. Only small parts slip through the bubble's skin. Inside, a curled helper holds two beads, and they click. A code strand grows by one, then two. The clay grain shows a narrow crack, no wider than a hair. Thin water, rivers slide along the walls and move fresh parts in and waste out. A dust of iron passes a tiny charge down a line. Each push helps a slow step. Each pause blocks a wasteful path. The bubble leans into the crack and sticks like a seed. By late morning, the film is about 10 degrees warmer than at dawn. The bubble's skin loosens and opens tiny pores. Fresh water rushes in and thins the salt inside. The code strand folds and hugs a twin. Copying begins. A wrong bead slips in. Heat shakes it loose. The right bead lands and holds. The strand is still short, but now it helps other steps go faster. A second bubble drifts near on the pull of a wave. Its cargo is different. More rings, fewer codes. The skins touch for a breath, then part. A few helpers trade sides. One bubble gains a mender that patches torn skin. The other gains a binder that catches iron. Both work better. The wave shoves them into a tiny pool no wider than a coin. The floor is soft clay striped with thin white salt lines. As the water sinks a finger width, the pool becomes a patchwork of wet and damp. Bubbles gather in the wet parts and nest in small pits. Here the code calls for beads in a set order that fits these salts and this heat. Chains that can read the order grow faster and last longer. Later the film thins to the width of a leaf. The sun presses hard. Many bubbles pop. Their cargo spills and smears across the clay. It looks like a loss, but the smear is a gift. Flat faces press beads close. Helpers find targets without a long search. A strand loops and tucks into itself and becomes a better helper. Another helper builds short, greasy tails that will turn into skins when water returns. Wind arrives and clouds stack high. A cool shadow sweeps the shore. The film swells and hides from harsh light. Pores and greasy skins open. New bubbles form from the tails made an hour ago. They round up cargo from the smear and close. The storm sorts and leaves far below along a vent wall the same day hums. Water is near 300 degrees inside a chimney, but a warm bath just a hand away. A charge difference pushes ions like ants through glassy pipes. A bubble holds at a pore mouth and harvests that push, adds beads to its code, then squeezes through and divides. Back on the shore rock, the sun sits low. A gentle quake jiggles a clay ridge. Weak pieces slide off. Strong ones stay. A bubble now holds enough code to guide a rule. Copy when salt is low. Mend when skin is torn. Slow when food is thin. The rules are not words. They are fits between shapes and place. Night comes and the film cools by 10 degrees. Bubbles drift into tiny hollows. Under a thin lid of salt, they rest. Inside, slow steps still run. A helper pulls a charge from an iron grain and passes it to a waiting bond. A skin mender lays a fresh tail along a thin spot. Close to midnight, the tide climbs a hand width. Cool water seeps into hollows. Salt thins. The lid lifts. A small rush wakes the bubbles. One swells, grows an hourglass waist, and pinches in two. Each new half carries enough code, enough helpers, and a skin that can mend itself. Many still break, but more than this morning now hold. Before dawn, red rims the clouds. Thick spots form where mats of bubbles and chains lie like soft felt. The mats are only a few millimeters across, yet they slow the next wave. The wave drops more cargo and moves on. The mat keeps what it needs and lets the rest go. Morning returns. The sun lifts. The day feels the same to wind and tide, but not to the tiny rooms. They begin with more tools, more code, more skins than yesterday. The same 10-degree swing and the same salt ring now push cycles that keep their shape. By noon, a helper appears that moves a charge when light lands. It does not split water yet, but this soft tap helps a hard step. The day ends as it began. A thin film on a warm rock. A soft crack with a tiny river. A bubble leaning into shade. Yet something has changed. More bubbles copy than break. More skins mend than pop. More strands help than harm. The line between almost life and life has been crossed many times. The sea does not cheer. The sky does not glow. But in spaces 1,000 times smaller than a grain of sand, the story turns and will not turn back. The turning will carry on again tomorrow. Morning returns to the same shore. The thin film warms, bubbles mend, and tiny codes copy with fewer stumbles than yesterday. A hand-sized mat holds through noon and night and slows the next small wave. What began as chance now acts like a habit. The habit spreads by dividing and drifting, by sticking to clay, by riding foam, by settling in cracks. Across many pools and vents, the first living things learn quiet rules. Hold, copy, mend, rest. Some of them find light and make a living with it without making oxygen, using sulfur or iron as partners. Others stay in the dark and eat the gifts of hot water, taking energy from the earth itself. Life learns many ways to live, and the more ways it has, the more places it can use. It spreads from warm beaches to calm lagoons, from vent walls to soft muds, and from wet rocks to the top skin of the sea. Time rolls like a slow tide. 1,000,000 days pass, then 1,000,000,000. Tiny winds add up. In one small cell, a new trick appears. It uses sunlight to split water and breathe out oxygen. Now light and water and common gas can feed a cell.
These blue-green makers, the cyanobacteria, build mats in
Wide flats and stack like small stony pancakes. Each day they add a little oxygen. The sea feeds it to iron, which falls like rusty snow. For a long time the air still holds almost no oxygen. The ocean eats it first. Iron and sulfur lock it away, but the makers keep going. Their mats spread across bays and shelves. More light is caught. More oxygen is made. At last, the bucket is full. The sea cannot swallow every breath, and free oxygen leaks into the air. It is only a thin share at first, a few parts in 100. The world begins to change. Oxygen helps and hurts. To many early cells, it is a poison that chews on their parts and breaks their codes. Whole families die when the new air reaches their pools. But some cells have small shields that mop up sharp bits. They add more shields and learn to use the new air. Using oxygen gives far more energy from the same food. A cell can power more helpers, build better skins, and fix more damage before it breaks. High above, a new shield forms. Sunlight meets oxygen and makes an ozone layer, thin but strong. It blocks the hardest rays that once stabbed the ground. The top of the sea grows kinder. Shallow flats become safer in day, and more cells can live near the light. The old iron snow eases because less iron stays dissolved when oxygen is around. Seas change their taste, shores change their color. The air smells less of matches and more of wet stone. Inside the micro-world, a bold act happens. One small cell swallows another, not to eat, but to live together. The guest keeps making energy. The host keeps the house. Together they do better than either alone. Many tries fail, yet this set fits. The pair copies, and the partnership stays. Over deep time, the guest becomes a tiny engine we call a mitochondrion. Later, another guest that can use light joins a different host and becomes a chloroplast. With more energy to spend, some cells grow more parts inside. They build rooms, fold membranes into stacks, and keep their codes in safe pockets. Bodies get larger, from a few micrometers to tens of micrometers, then more. They move with soft hairs, or creep with flowing edges, or float in sunlit water. They form colonies that hold together after dividing, simple chains and sheets that share walls and food. The line from single to many begins. For long ages, life stays small, yet the world's face shifts. Mats push mounds up in warm seas. Microbes paint rocks red, green, black, and white. The air's small share of oxygen keeps climbing and dips now and then in long swings. Ice grips the planet more than once, then melts. Through these tests, cells refine their tools. They store food for dark hours, grow simple shells, and talk with tiny signals. Much later, new bodies appear. They are still soft, but larger than any cell and show simple parts. A front and back, a mouth and tube, a wide frill, a stiff frond. We call them the Ediacaran forms, faint quilts in thin beds of sand. Soon after comes a burst of change. Bodies add muscles and hard parts. Eyes appear and catch light. Jaws bite. Worms churn the mud. This is the Cambrian explosion. Green spreads to land much later. Films of tiny life darken damp rock. Then plant cousins take root near fresh water. Stems rise a few centimeters, then a few meters. About 400 million years ago, tall trees make shade. Wind sings in leaves. Amphibians watch from a pool's edge. The air now holds many parts of oxygen in 100, enough for deep breaths. Dinosaurs will thunder. Flowers will open. Birds will glide. Mammals will wait in the dark, then rise after a space rock ends a long age. Grass will make wide plains. Ice will come and go. At last, a small branch of life will learn to make tools, stories, and names. It will read the quiet marks left by mats and waves and thank a thin blue shield for softening the sun. But on that first day, none of that was known. There was only warm rock, films, shy bubbles, simple codes, and patient cycles. From those small starts came reefs, forests, wings, songs, and at last your question. What was Earth like the day life began? It was harsh and kind, simple and rich, loud and quiet, and full of small rooms where tiny makers learned to last. That was enough to start a world. The rest was only time and patience.